Thank you for joining today's webinar, Overall Equipment Effectiveness, also known as OEE. Today, our presenter will be Mr. Keith Groves. Now, Keith has worked in manufacturing, particularly with CIS for nearly 16, 17 years. He has nearly 3 decades in lean manufacturing, and he has worked extremely hard in lean manufacturing since, I say, 1995. In 2006, Keith worked on a lot of different projects, but particularly he developed a new program for the center called Business Transformation, which is a huge success for us. This is one of many holistic approaches and moving into businesses into the future. So today we're going to talk a little bit about that and how these types of tools can also increase your company's ability to compete in today's global market and improve profitability. That being said, please help me welcome Mr. Keith Groves.
Thanks, Andre. I appreciate the introduction. This has been a while since we've done videos like this, so I'm looking forward to having a good time with you today. And we're going to spend some time talking about, as Andre said, overall equipment effectiveness. And I know talking with manufacturers and traveling around, that's a concern, the ability to develop capacity within your companies. And this is a portion of that plan to make us more effective as far as our companies are concerned. Let's do a little bit of kind of where we're at, is where this overall equipment effectiveness fits into the scheme of lean manufacturing. And if you think about it, you know, this is one of the tools in the house of lean, one of the tools that we use every day, that we keep close watch on how our equipment is working, how our people are working, interacting with that, and how we can continue to move forward. You know, really, this is one of the pivotal pieces of our lean manufacturing operation. Is we have to have machinery that does what we need it to do, when we need it to do it, and create the quality products that we want as we go forward. So this is going to be a quick overview, trying to pull out a section of this. And so I just wanted you to see where the TPM is kind of, OEE falls in that TPM banner. So it's just one piece of the TPM program, and we're going to talk about that today. As we go along, if you have questions, please use your chat box to pose those questions, and I'm sure we'll have somebody that'll bring that to my attention if I miss it. But we'll try to field your questions as we go forward. We don't want to miss anybody's comments that are there. So if you're familiar with TPM at all, it's a process that maximizes the productivity of equipment for the life cycle and the entirety of life of the equipment. Now, here's to me a key point that's going to be made over and over again as we go through this little short presentation. This is involvement of employees. This is an interaction. You know, if we're talking about as a company changing culture, trying to change the way we do business and trying to do those things, it becomes extremely important that our employees are involved in that. And TPM, or overall equipment effectiveness, creates that environment. Okay, it creates an environment that encourages people to be involved in the safety practices, in quality of the product, in cost and delivery, and creativity. And the more we can incorporate and give incorporate the employees, the more involvement they have, the more ownership they have, which means we have a better opportunity to observe things and to identify areas for improvement as we go forward. And that is really an important piece of what we're doing. So why should I care at all about this? Well, the goals of TPM are important, and what they can do for us. As I just mentioned, it's developing people who are equipment knowledgeable. I always say at this point when we're talking about that, we're not trying to make mechanics out of our employees. And having been in maintenance at some point in my life, I don't want operators being mechanics on machines. I do want them to be able to identify when things aren't going as they should be going. They're there more than I am or was. And they can tell you when something's not going right. So it's important that we develop them and help them to understand more have more knowledge about their equipment that they're using. It also helps to create a safe, quality work environment when we have equipment that's engineered properly. And I think this next one goes along with, the next point goes along with the first one. It increases enthusiasm and creativity flourish, because we get people thinking on their, by what they're doing in the areas they're doing it in, gives them, they create ideas about how it could be better. And then we want to maximize the productivity of the equipment by measuring what OEE is all about. And that's really where the core of what we're going to talk about today is. How do we measure that? So I guess I would ask the question now, how are some of us, some of you gentlemen and ladies that are in manufacturing and in companies, how do you measure that currently? If you want to go into the chat box and answer that, that'd be fine. Or if you want to speak up, that'd be great too. Any comments on that? How are you currently measuring equipment effectiveness?
We're just at the beginning stages of doing that, and we're starting to look at cycle counts and different causes actually for what the delay would be in the cycle time. We're still in the process of identifying all of our sources of delay, just because of the type of business model that we have here. It's a little unique compared to some other places. So this is a good educational tool for me to be able to take and use with my compatriots and counterparts in Canada. Good.
I think you'll find that, and as we go on and we start talking about how to calculate this, that what you just mentioned will come very much into play and will help you see a little bit bigger picture of how it all fits together. So I appreciate that very much, Chris. Thank you. Okay, so there's an importance there that we have a program in place. The goals of that, and you'll see that these are 4 zero goals. We want 0 unplanned downtime. Downtime is not a good thing. We don't want any downtime. So we want to define what planned downtime is for maintenance. We want to eliminate breakdowns where possible. And there again, it's tracking and looking at what is causing those things and trying to identify causes in how we can eliminate those things. And then creating 0 defects. So you begin to see a kind of a pattern. One, we're talking about machinery that's running, that's doing what it's supposed to do. And now we're talking about running, but creating product that's good, not defective product. And then we have one called loss of equipment speed. And this is one that we sometimes don't, operators don't realize this, that, machinery is designed to run at a specific speed for optimum production, and being able to monitor that to make sure that we're not running it too fast, because that could cause problems, or we're not running it too slow, and that could also cause problems. And I notice this point, that typically industry loses up to 10% productivity due to a loss of 10% of machine speed. So just kind of goes hand in hand. If the machine's not running properly, then our throughput, our productivity is going to be affected. Also, by one of the goals is safety. We want to make sure that we create equipment and environments where operators are safe. Safeguarding, we're very conscientious about doing that, but also about, how do we design our machines so that we don't put our operators at any kind of risk, even in a down position when it's not running, to make sure that those things are safe and environments are safe, so we don't have potential for accidents to occur. And we know what the cost of those is versus, everything else that goes on. So there's some real good goals that TPM can help us to achieve as we go forward. This is one company that was looked at. There are probably many other things. And I don't know how many times we talk about cost, but I don't know how much time we actually spend with our operators, making them aware of what these costs are. Because if you walk through plants and you look at certain things, such as hydraulic oil on the floor, if there's a leak associated with that, that can be by using an active TPM program over a 2-year period. This company recorded a reduction of 57% in oil consumption. And we don't think about water consumption, but that's a cost that's there, and some reductions there about can add up to dollars that are pretty high, and people just don't realize those kinds of things. And the other side of that, from maintenance side, is when we have to contract maintenance, when we have specialized products that we have to have people come in and work on, or and repair costs of those machines, the cost of those parts that were available is tremendously high. So, just the awareness of those kinds of things, that people can see, this is how I affect, these cost control. We are making more important now that we make employees aware of how they affect cost on the shop floor. And you think about those kinds of things. The quality of the product affects the cost, the materials that go into it, the way we, the diligence with which we keep our machines clean and operating at high levels. That's a cost that's out there. So we're talking about an overall savings, could be as much as 25% increases in productivity, and profitability could go up if we can continue to control those costs, and making employees aware of that is part of this process. So you'll see that as we start painting this picture for overall the overall picture, how that can be affected as we go forward. Okay. Enough about the why we should do it. I think that's pretty apparent. How do we do that? Well, let's start with a little story. Let's talk about this. Let's think about in your roles, and you may have one of these may fit you. Let's think about when we have a problem with our machinery. And this is called the production folklore. And we're going to start with some maintenance tales. And the first one we're going to start about is the manager's tales. So think about what happens when the machine goes down. And the manager's response is, well, I don't have time to shut this machine down for maintenance. I've already lost so many days this week, or I'm already running behind. I can't afford that because we had a breakdown on Monday. And if you think about it, a lot of times we're, as managers, we're having to shuffle things around. We're having to work through things. It becomes pretty chaotic at times. And we just can't seem to find time to be able to schedule machinery to go down for maintenance. And that's a tough one to have to swallow, because we know that things are going to happen. So think about how machine failure impacts the production manager's work life. They're not always in the best mood when it goes down. And we work in a reactionary mode, and we sometimes call it firefighting, because that's what we have to do. They just go from one fire to the next sometimes, if we don't have control of our processes. And so their life becomes very, very difficult as a manager, because they're kind of in between. We've got to have production, but yet I've got to deal with these issues that are on the machine. And so it kind of becomes a little bit chaotic. And so we have to be aware of that. And then the next one in our tale of machine of production is the maintenance manager. So what is the maintenance manager's role in this when it happens? Well, he kind of like Superman. He's here to save the day. He's coming in, he's going to swoop in, and he's going to make everything better, right? Well, that's the theory, and that doesn't always happen that way. They come in, they've got to do some very important pieces of this. They've got to first determine what happened, diagnosing problems, deciding on what kind of parts are going to be needed to fix it, finding those parts that we're going to need to fix it. That becomes a problem sometimes. Getting the people lined up to work on it, that becomes a problem sometimes. And it just takes a lot of extra time just to get ready to make that repair. And you may have experienced something like that as a maintenance manager, or working in or seen what your maintenance department does. And they've got a lot of responsibility. And there's a big burden there to, what's priority, what comes first, and how do we deal with that? So the maintenance managers have a big issue to deal with. And then you get into the production scheduler, the guy that's probably in my opinion, the most has the toughest job in the whole plant, because they have to be the ones that have to schedule for the production and the plan. And they spend a lot of time putting a plan together over the weekend and end of the week come Monday morning, they put it out, there it is, and by noon of Monday, that program is shot. Nothing worked out, it didn't pan out, or we had a machine go down, so everything changes. And now how they feel, they have to go back to work to try to recover the rest of the week and then try to move ahead. So that's a difficult position. I think it's the most thankless job in the whole plant most of the time, because they're constantly pushing from both ends, trying to make things happen and trying to keep things moving. Then you get down to the operator. Okay, the machine goes down. What does the operator do? They're looking at, well, what's next? What are we supposed to do during this time? So what do we normally do? We might spend some time cleaning up, or we might be doing something else. But we're also always thinking about what's the next plan. And they're kind of in limbo, because they're kind of at everybody's mercy, waiting for instructions of what to do, waiting for, the repairs to be made, and thinking about what the future holds. Because if we don't get it done now, there's obviously that opportunity for overtime, of which we probably would rather enjoy our weekend than we would working. So there's a lot of stress that goes on there, and firefighting also takes place at this point. So the operators are, machine's broken again, I'll have to wait for maintenance kind of attitude, and that's a reality of what happens a lot of times. I want to show you a little video, and this is kind of a symptomatic of, if we don't develop our people, sometimes what happens in manufacturing. And see if you can relate to this in any way. This is a video we use in some different areas, but I want you to watch what happens here.
That's not good.
But this pretty late.
Somebody will come. Anybody out there?
Do you have a phone?
Sorry. Somebody. Hello. There are two people stuck on an escalator and we need help. Now, would somebody please do something? I don't believe this. You gotta be kidding me.
I'm gonna cry.
Well, there's nothing else left to do. See.
Hello. Hey, don't worry about it. I'll fix it in a second.
He said he can fix it. All right. All right. That's more like it. You said you can fix it.
Anybody ever been to an experience like that before? We need to educate them and help them to understand their responsibility, and take ownership of the properties that we ask them to operate every day, and trying to keep them moving. And so by the more we can identify how they can do that, and the more understanding they have of what the expectation is, then the likelihood is that we'll have more involvement, that we'll have reduction of some of these things that we've been struggling with, and we're going to talk about some of those things. But this is OEE is really about identifying opportunities as we move forward. All right, any comment about that? We move forward. All right, here we go. So the mechanic, he's kind of the next guy in the tail, because he knows that breakdowns are going to be inevitable, and he's kind of grown accustomed to just dealing with things. But there's just so many of them that can go around, and we get very stressed out and very slim on availability of their time, and the things that they have to work with, such as having the parts available having the help to help them do some of those things that are there. And it gets to be it's a very cumbersome job sometimes. Not always a fun thing to do when you have breakdowns and trying to get there, because everybody's wanting you to, you know, have magic wand or something, you just wave over it and fix it, and that doesn't happen. There's a lot of things that have to come to place. All right, so the moral of the story is, if you don't schedule time on your equipment for planned maintenance, it will schedule itself. It will go down, and it has a kind of a, you know, it has a lot. There's a life cycles within that equipment that are going to go down. It's our ability, it's our job to try to figure out when those might be, to be proactive rather than reactive. And that's really what helps us to understand a little bit better about what's going on and how we do that. All right. So let's look at a few things here and start talking about how we do this. We're talking really about reliability maintenance. And that's really what we want to do, is we want to be able to do things that help keep our machines reliable, doing what we need them to do. We're going to focus on, this kind of relates back to the continuous improvement definition, but it's a systematic approach to eliminate losses. Once planned and autonomous maintenance are initiated, and new equipment purchases and designs are based on minimizing total equipment life costs, focused improvements play a vital role in increasing equipment performance. And then focused improvement events or projects are chartered, driven by collected data to identify specific opportunities. And so that's kind of what the outcome of this is, as I said a minute ago, becoming more proactive rather than reactive. These improvements are typically team-based. We want to get people aimed at reducing those 6 major losses that take place. And we're going to talk about those here in just a second in machinery. So let's take a minute to review those losses and specifically what a focused improvement team activity is charged with reducing. The other focus parts of this is to each employee is empowered to make continuous improvement. You know, that's a culture issue sometimes. How much leeway, how much liberty do we give the operators in making decisions on how to improve the processes? And so this has begun to grow that relationship, to grow that culture that says we need everybody involved. We need ideas from everybody on how to do that. And the operator of this machine, they're the best ones, because they're there most of the time, more than anybody. We can collect data and review the identified opportunities for improvement. And then the last one is that we use natural work teams, the teams within the operation, to try to come together to think about as a big picture. You know, sometimes individuals can be have tunnel vision because they only focus on that particular area. This kind of opens it up and says, okay, team, we need some outside eyes looking at it. We need everybody thinking about it. How do we improve this? How do we make these changes and create opportunities for improvement? And so the 3 components of OEE is availability, performance, and quality. Now, a lot of times, if we don't have a good program in place to calculate OEE, we might just be focused on performance. You know, we're so consumed with how much, you know, are we getting enough material? We're getting enough product out of the system. And so we kind of focus on that, or we may just be focused on the quality. But this process takes all 3 aspects into place. So we talk about availability. You know, think about when and how often do you lose availability of your equipment? What the kind of occurrences are you having? Once you determine the loss there of availability, then, you know, you consider things like setups become an important piece of that. How fast can you go from product to product? How quick can you change it over? You know, a lot of times the example used in this is NASCAR and some of the racing groups, how fast they can change tires and put gas in cars. And that kind of sets the mindset of, okay, from start to finish, how fast can we do that? So setups becomes an important piece of that. The frequency of equipment breakdown and maybe it's based off of the different types of products that we run. I know in my experience in manufacturing, we've had in some stamping and die operations, some tooling is a much more complex than others. You have a lot more moving pieces, therefore you have more opportunities for accidents and things to happen. And that becomes a bigger piece of the puzzle then when you have a very intricate, detailed tooling. And then measuring uptime. Uptime is the calculation. Uptime divided by the available time gives you a percentage of uptime. And that can be a good indicator too that we want to look at from an availability standpoint. Then we move over to performance. We're talking about what is the preferred, the design rate at which that machinery should run. And you all are well aware that if we run one too fast, that creates problems with the operation of the machinery not being maybe as precise, but equipment can wear out quicker when you run it faster. And the same thing goes with running an equipment below the optimum speed. If we slow it down too much, sometimes that can have an adverse effect on the equipment, especially the electronics, because motors don't always operate at a reduced speed unless they're designed that way. Then you got some some things there to consider. But what is, having an understanding of what that 100%, what is that maximum design rate which we should run, and then the measuring machine rate performance. What should it be? Well, that's another calculation. We take the actual what it does run divided by what it's capable of doing to see what the percentage there is. And so there's a lot of data that's collected here. We're going to show you some opportunities on how to do that in just a moment. But then let's talk about quality. That's really the one that we're sometimes most concerned about. And the question is, what is our quality rate? How well are we doing at that? If we've got machinery that's not producing what we need it to do, then we know the costs are accelerated and increased because of having to redo those parts or remake those parts. My philosophy in manufacturing, if anything we say we do begins with RE, then we've just added more money to it because we've redone it, reworked it, remade whatever, re-inspected, and we just added more cost to it. So we want to understand from a quality standpoint, is it a repeatable process? Can we have that consistency there? And then we measure that quality percentage by good units divided by total units. And so that just kind of gives you a glimpse of the importance of all three of those. Now, any one of those is important, but all three of those together is a good indicator, is the best indicator of how well we are doing in our productivity pieces that we're, things that we're trying to produce. So we want to look at how to do that. Now we're going to talk about some basic ways to get those things, but let's think about some definitions here first. We're talking about available time. This is one thing that I think sometimes we don't make enough, we don't emphasize it enough, because available time is the total shift time less the planned downtime. And by planned downtime, we're talking specifically about lunges and breaks and cleanups, those kinds of things. Maybe it's team meetings that we have every day that we know is scheduled. Those are good things, but and some of those are necessary things, but it does take away from our available time that we have during the day. But we need to understand what that available time is. If we say our shift is 8 to 5, we don't have that full 8 to 5 time available. It's less those planned times that we are down. So we need to understand that. And then we have downtime. We have things that happen. We have changeovers, breakdowns, unplanned downtime, anything that can stop that machine. Maybe it's the machine malfunction or whatever. Maybe it's a material flow that stops it, but that's downtime. Cycle time is the total time from the beginning to the end of the process. From the time we started to the time we ended, and we usually use exit cycles to determine the rate at which those things are coming off. And we can plot those, and we can do a lot of things with the graphs to show us that, how consistent we are in producing product, but cycle time becomes an important factor, and we'll see that in just a moment. And then operating time is the time the machine, the total time the machine was operating, not including downtime. Okay. So those are the kind of things we're looking at, just to get some ideas of how they're going to be used in upcoming calculations. Excuse me. We talked a minute ago about the 6 specific losses in manufacturing or equipment. One of those is equipment failures. That affects availability. We have setups and adjustments when we have changeovers. You know, looking at our changeovers in detail tells us where are we spending most of our time. If we're spending most of our time in setups and adjustments, which is usually the case, then there's some improvement work that needs to be done there. But we can simply track that time, and that there again, that all goes to the availability that we have. It's unplanned downtime. Then we have idling and minor stoppages. That's a pretty broad term, but it all goes to the performance of the product, of the machinery. And then you have reduced speeds that factor into that. The next one is process defects, which goes to the quality of the product and the quality of products produced, which also leads to reduced yield. So those are the 6 major areas of loss. Those are major categories. Now, one of the things that I would suggest that are be suggested as you go forward is decide in advance what those things are that you want to measure as far as downtime losses. And we're going to talk about that a little bit more in detail as we go forward. But the team together needs to formulate ideas that will help everybody be aware of what it is they want to track. So there's some steps involved in the OEE data collection. One of them is we got to understand what is the data we want to collect and how are we going to collect that best. Who's going to do it? Where's it going to be done at? How are we going to record that? We're going to look at, once we get that, we're going to prioritize the improvements that need to be made based off the data that we gathered. Then we're going to dig a little deeper as we identify what those defects are or those problems are, and to find out and to get down to root cause. Okay, root cause is that ultimate level of definition that says I can start and stop this problem. I can see how this problem got created and what caused it to happen. Then I can put things in place that would prevent that from happening. And then we develop an overall improvement plan. How are we going to maintain this program? And sometimes this is the part of the steps that we don't continue. We don't finish up. We don't have that plan in place, and formalizing that and making everybody aware of their involvement in that plan it leads to the sustainability of that in long term. We are doing a lot of programs right now within the Center for Industrial Services, helping people to understand how important coaching is and how to direct teams in moving towards those implementable programs that help sustain productivity over the long term. And that's an important piece of that, but sometimes it gets kind of pushed back to the wayside a little bit. We don't get to that point. We're still focused on these losses that we have, rather than putting in a plan for improvement and how do we sustain that over the long term. So those are the things we're really going to focus on kind of as we move forward. So this really comes down to a 6-step process for OEE, calculation and implementation of OEE. We already talked a little bit about it, but the first step is collecting OEE data. Once we get the data collected, the next step is to analyze what had happened, when it happened, where it happened, how big a problem is it, all that kind of information that'll help us understand fully what the problem is. The third step of that is to prioritize those improvements. What do we need to do first? What's going to impact it the greatest? And then we can continue to knock down those lists of improvements that need to be there. Determining root cause, why things fail. Sometimes it's components within the machinery that fail. I learned this the hard way one time. We had packaging machines that had so many cycles, they did every day, and we found out that some of the micro switches that were running the information only had a life expectancy of about half of what we were running every day. So we had a lot of failure there. So really understanding your equipment You know, we don't want the operators doing that. Okay, we want that, but we want to gain that information because we want to capture that information so that we have that, so that we can diagnose things quicker by understanding what has happened in the past. And that's when we find some of those root causes of things. How are we going to fix that? We got to put a plan together of the implementation to keep that process going, the improvement process. And then we want to share results. You know, we want people to see what was done, how we did it, and how we can show the benefit of going through a program like this. This is kind of it's an important piece for us to, you know, if we can improve capacity, improve productivity, then we've made some tremendous steps in the process. So let's look at some detail behind each of these real quickly. The first one is, and I don't know what kind of format you use or what you're using currently to collect data for your area. I call this an hour by hour board. There may be something that they use similar to this, but basically this is production run for the day. And you see the hours, here's each hour, 7 to 8, 8 to 9, 9 to 10. And notice that they got some breaks in here for, this is a 10-minute break here. There's a lunch break here. And you see some other breaks that are in there, but here's the production. Here's the production goal. So this is how many we produced in this hour, how many pieces did we produce? Here's the goal. Did we have any scrap that occurred during that time period? If there was downtime, how long was the downtime? And if possible, what was the cause of the downtime? And so this is something that the operators keep up with. So they're beginning to take ownership by doing this because they're watching, they're monitoring the process. And so you do that through the whole day and you come up with that. And so at the end of the day, you come up with a data sheet. This looks like this. So we had a total of 535 pieces produced. Our goal was 716. Well, we know that that's a problem already. We had 20 pieces of scrap and we had 70 minutes of downtime. That's 70 minutes of lost production. That's 1 hour every day. So if we lose that every day, that's a problem. If we lose that over 3 shifts, that's a bigger problem. And so we need to understand how important these little pieces are. It may not sound like a whole lot right now, but it can really, when we start putting it into the formula, you can see what the effect's going to be. So this is just one way of gathering information. Now there's some, this stuff we'll be glad to come by and visit with you or share this stuff with you. If you got questions about it or would like to see some examples in further detail, we can do that. Just let us know as we complete this a little bit later. So what does this sheet do for us? We're talking about availability. So we're going to take our runtime, which is our planned production time is 430 minutes. And our runtime was 430 less our scheduled, right? We had some planned time that was down for a total of 80. Our availability is 83.7%. So if you multiply that by 100, that's 83.7%. The performance rate for this particular run with this data, the ideal cycle count was 36, but times the total count, which was 535. So we can go back one here and you can kind of see where these numbers come from. So here's our total production here. And we had, we had 36 pieces of the cycle time is 36 pieces. So that's now converted to seconds. So we had the total available time, runtime here was 21,600, 36-second cycle time for each piece times 535, which means we're at 89% of performance rate for this particular day. Then the quality count, we took the good count, less the scrap divided by the total count, which says we're at 96.3. This just gives us a snapshot in detail of what our day looked like. So if you ask an operator, well, how'd you do today? Went pretty well. Well, what does that mean? So I heard a guy say this one time, and please don't take this the wrong way. He said, in God we trust, everybody else has to bring data. So what we want to do is we're bringing the data. This is what we did. This is how it really looks. And so this begins to look at, if you think about it from the big picture standpoint, our OEE. So we typically take each of these categories and multiply them together. So 0.837 times 0.892 times 0.963 says times 100, which gives us percentage. says our OEE is 71.9%. And our loss capacity is 28.1%. Now I understand what kind of day you had, right? I understand we lost a little over a quarter percent, of our product capacity today. And that's not a good thing. But this simply paints the picture for opportunities that we can look forward to and try to find out what went wrong. So once we do that, we start analyzing what the data was. And you can create all kinds of charts. You can do Pareto charts, you can do histograms, you can do pie charts, you can do all kinds of things, whatever detail works for you, but some way to highlight what those things were. A minute ago, I said it's a good idea for you to get us together as a team and determine the types of loss categories that you want to track. In this case, they looked at setups and adjustments. They looked at quality. They looked at startup times, speed loss, idling and minor stoppages, and breakdowns. Kind of going back, let's just pick this one out and startup. I use this when we start talking about available time. Think about opportunities at the beginning of the shift and opportunities at the end of the shift, right? So if we start up at 6 o'clock every morning, when's the first part coming off the line? That's it. It's like, well, we got to get the machine warmed up. We got to do this. We got to do that. Well, that's lost time that we don't that we don't think about. What are the opportunities? What could we do to make that better? How could we come in and start that machine up on time and run as quickly as we possibly can? That's the opportunity we want to challenge them with, is how do we do that? But until you plot it out and start looking at it and start comparing, you can begin to draw some conclusions as to what really is causing the biggest issues that you're having. In this case, it looks like the idling and minor stoppages might be an issue. So once we've collected all that data over whatever time period you want to look at, then you can aggregate and kind of start stratifying and identifying what it's telling you. And since a lot of people are visual people, means they have to see things. That makes pictures mean more to them. We're gonna show them a picture of this, making the graphs become more meaningful than simply creating just numbers on a piece of paper. So anything you can do to make people aware of and visualize a little bit better what's going on, the better opportunities you have for getting people to sharing information. So this is one way to looking at it. Now, once we get this data, then we're going to go to our next one and we're going to start prioritizing. We just simply used a pie chart here showing the different areas, and so by colors and wedge sizes, you can kind of tell which ones are bigger than others. And so we're going to start identifying and narrowing down, go into detail about, well, what are these idling and minor stoppage things that are happening? Once we've done all that, we can make it real visual. And then once we get there, we're going to get down even to a deeper level within that category. So we're talking about, in this case, is what we call data mining. We're going to break out the idling and minor stoppages into jams, chips, inserts, and others. That might be a lesser category, but we're simply trying to drill down, which is most, it's kind of a priority thing. Which one of this is the biggest and which one's the most important? Trying to figure out how do we eliminate jams? How are we going to focus on that? In one of the processes that we've in the coaching process that we use, we only want to work on one item at a time. In Deming cycles of PDCA cycles of learning, you target one condition that you want to identify, and you work through that until you resolve that issue and make sure it's corrected, and then you go to the next one. So you've got a deliberate activity just focusing on how do we improve that. Once that one's done, then we can see what the effect of that was on the process, and then you can go to work on some of the other ones that are there. So this creates a very deliberate process for you to go through, and so you're narrowing and driving down to each of the different categories. Once we do that, then we're gonna find root cause. What caused it? Can we correct? Can we put some temporary things in place to fix that, to see if that affects it or not? This is where the cycles of learning comes in. We try some things to see what affects it one at a time, but so we'll know what the effect of each one of those is. But we're narrowing it down to the root cause and finding out what what we can do to put in place permanently to make that problem go away. Once we do that, then we can begin to, once we've determined root cause, then we can have our implement plan created. And notice in this case, this was this turret lay that they have been going through. So the problem description is eliminate jams due to operator lack of knowledge. Sometimes it's an operator issue. If you go back to the previous slide, you'll see that as they were going to dig down into that, they found that there was a big portion of that was operator knowledge. This is actually lost its little tag there, but this is operator knowledge. So there's some training issues that might be there that we need to identify and work through. So we're going to eliminate jams by educating the operator on proper procedures for loading. These talks about interrupting the flow of the equipment and keep us from being efficient. So we're going to look at our training program, the documents that go around it. Sometimes the training wasn't sufficient. I mean, think about it. We're guilty sometimes of getting bodies in there and we don't spend a lot of time training them. So sometimes we create our own opportunities there. So we have questions about it. We're going to list a summary of steps. We're going to detail what the problem is, and then we're going to look at the improvements that we can do that and how we're going to move that forward. So we're going to do audits to evaluate the current methods and to continue that for 2 or more months to track the data to make sure we've made improvement. So we create a plan to move forward, and we define that with the team so that everybody knows what's going on, where we're going, and how we're going to get about that. We want to use this opportunity to show what we've done and how we've gone about the improvements. Okay. And by doing that, we're doing a shared results. These 1-point lessons. I don't know how many of you do 1-point lessons. We encourage companies to use these. These are quick little synopsis of what the problems and improvements were. This one in particular happens to be about a motor cooling fan accessibility. It was inside of a cabinet. We couldn't get to it to keep the airflow going. And you notice they show the current condition when it's really dirty and messy and it's not doing what it should. You see all the buildup around these fan guards and things in there. Go in and clean it up really good. They came up with a solution of pulling a piece of a hose outside and they put a filter on it. I've seen companies, and we've encouraged companies sometimes to use an exterior filter material on the outside of a machine to catch the dirt as it goes in. So the operator could do that. That becomes an operator maintenance thing. But these little 1-point lessons are important to demonstrate what the team came up with. Okay. And I thinking about this, when we go into the full-blown program where TPM, we talk about these kinds of things, these 1-point lessons. I don't know if you've ever noticed or not, but if you've ever gotten a McDonald's sack and you look on the bottom of the McDonald's sack, there's a diagram on the bottom that shows the operator how to stack stuff in that sack, where the hamburger goes, where the French fries goes, where if you've got multiple sandwiches, it just tells you how to fill the bag up. Well, that's a 1-point lesson for a training point for a new employee to learn. These are really good ideas. These are really good visual ways to demonstrate what the expectation is and what can be done. Now, we didn't make a mechanic out of the operator on this. All they're required to do is to change that filter when it gets dirty, and they make that judgment, right? Because we know how important the filter, the quality of that air going into that area is. And so in order to prevent that motor or prevent those components from overheating or doing whatever, they simply can change that filter. And it's real simple for them to do without even shutting the machine down. They can do that at any time. So that's just one way of doing that. And there's other opportunities that maybe you've got some ideas of things that you would be willing to share with us that would help to enlighten somebody else. Any comments on that? See a comment here that says, I always say maintenance happens. You either pick the least painful time or the machine picks the most painful time. That's exactly right. We don't have any control of that if we don't take control of the operation. I had another comment here sometime back that said, we use older reliability centered program metrics for the equipment, but are transitioning to OEE. So, and I think that's an important comment too, because this process and this way of relating that information is much more acceptable to the operators. They can understand that a little bit easier because they're there all the time. They understand those pieces because if they're tracking that information, they own that information. And that's really, it's easier for them to understand how it fits into the picture of that. All right, so, that's kind of where we are. This program can be, if you do the full-blown TPM program, it can be at a, however big project you want it to be. But typically this is incorporated in that, and we'd be glad to discuss in more detail how we can help, how we can participate in that with you. At this point, I would just entertain any questions, any further comments you might have about the program, about what we've talked about today.
Hey Keith, from the chat, we have a question of what is a typical or average OEE of a company just starting out, and what is considered world class?
Well, you typically think of when you're calculating like productivity cycles and things like that, you would think anything over 85% is kind of an acceptable range. The closer you get up to 100% or 90%, 95%, I think that's the objective is, when you get up above 90%, those increments come really slowly. But I think you can see, I would I always look at it from what gives us the biggest bang. That's usually throughput. How much throughput can we get out utilizing our time? And if we are losing productivity because of things that are occurring upstream, then we need to fix those things. It may not just be the machine that's causing us the problem, it may be something upstream. So I would say in that, typically 85 to 90% in all those areas is probably pretty typical. When you get above 90, in 90 to 95, you're getting up into the world-class range there. So
Very nice. Very nice. Thank you, Keith. Another question we had in the chat is, what are typical challenges to using OEE?
Well, if you're not currently doing anything to track the data, that's usually a challenge, is to get people to fill the boards out and do it correctly in a timely manner. I think that's one of the things. The second is, I think, that can help that is interaction with the team leaders, as far as coaching them on, how to do that and when to do that and why it's important. So maybe more frequent visits by the team leaders that are looking at those boards, rather than just saying at the end of the day, we got them all here. That's kind of after the fact. So as we're going through the course of the day, maybe it's periodic visits to those would help that. But I think the data collection is the biggest piece of that. And then, the second part is how do you encourage, how do you build creativity? How do you encourage your employees to participate in those improvements? Is another thing, because they're not, if you don't have that culture in place, it's hard. That's a hard transition. So some other things you might have to do to get people thinking along those lines of, I really do work here all the time, and I really do have responsibility for this. So just giving them an opportunity, giving them a voice in sharing those ideas that they have, because they do that outside the plant. They're involved in a lot of things, and they're leading programs outside the plant a lot of times. So just I think, the data collection first, and then how do you get them involved? How do you get them to have buy-in into the program?
Yeah, that's some good info to know about. I mean, another one is, how does tracking production rate through OEE integrate into higher level decision making and strategy?
Well, if you look at the percentages, okay, of what each component of that is, the quality and the productivity and the availability. If you look at each one of those, it may help you to understand, well, if we could improve 2 of those, we might not have to purchase a new piece of equipment. You know, sometimes when we look at it, we kind of get satisfied with what we're seeing. We just say, well, it's running or it's not running. We kind of accept that as the status quo. Then we say, well, we got to have more capacity. So what are we going to do? We're going to have to build, you know, another piece of equipment, or we're going to have to do this, rather than trying to improve what we have. There's a lot of conversation right now, and we have a gentleman that does a lot of stuff with Industry 4.0, you know, that's trying to automate a lot of stuff, a lot of equipment. You know, a lot of people are going to these little cobots and things like that, and that's great. But until you can get your system, you know, running at a steady pace, that's going to be a problem, because you can't automate it if you can't operate at a steady pace. So they're, you know, looking at each of these factors independently, and then looking at them as a conglomerate there, it kind of paints a different picture of what you're really capable of doing. And you may be surprised when you start putting the numbers to it. You know, if you're losing 25% capacity because you're not utilizing your time availability, that's a big issue, right? That doesn't cost you a whole lot to fix that. So those are the kind of things that I would be looking at, and that's how they kind of fit into me.
Thank you, Keith.
Okay.
Another question we have here is, are you aware of any automated data collection tools that will integrate easily with our equipment or processes, data and collection and data sheet output?
Yeah, there are a couple of companies I know of specifically that do that. It really depends on your equipment, you know, the age of your equipment, and the electrical, you know, components of that, you know, what kind of technology is there to tie into. Most of that's tied into some microprocessors and things like that are already there. They can just go in there and pull that data out. So yeah, there are programs that are already set up where you can go in and capture that electronically and do that. I just think, you know, I'm an old school kind of guy. I like for the operators to interact, and I want to see them understanding the data that's coming out of there and how it gets there before you know, we go to electronics, because that's expensive when you go to do that. But still, it's a good thing. It helps everybody to understand it. But yes, there are systems that are out there and companies that I know of that do that kind of thing specifically, and it's there.
Last question. Your example seems to focus on a piece of equipment. How would we apply this to manual processes with little to no equipment?
Well, I mean, there are certain components of that are still, you know, there's got to be manual equipment. There's some loading cycles that are there, some things that will help with the loading and unloading. There's, you know, if it's a trim press or whatever, there's moving components that are there. They could be blade sharpened. It could be a whole bunch of different things. It would just be a matter of looking at follow the process, right? What are the defects that we're seeing, or what are the defaults that we're finding, and then tracing that down to root cause, and then trying to track it that way. So it's not kind of like mowing your grass. You know, you mow your yard and it looks good until the blade gets dull, then you change the blade out, right? So you're looking for those indicators that says something needs to happen differently. So I think you can apply it to any kind of machinery or manual operations too. There's things that prohibit people from being able to do the jobs properly and having, you know, the equipment there to do that. So.
All right, well, that looks like it concludes our questions then. Andre?
And again, thank you, Keith, and we look forward to our next webinar.